tests for the anions. We've already looked at the test for cations, which was the flame tests, and the precipitation test with hydroxide solution. But to identify the formula of a compound, we need to know not only the cations, but also the anions. The word anions, we don't actually need to know for GCSE, but anions just means negative ions. The way that I remember that, by the way, is just there's a minus on the word anions there. So the negative ions, what you have to know for GCSE, are sulfate, carbonate, and the three halides, chloride, bromide, and iodide. So I'm going to do the sulfate to start with. Sulfate is SO4 2 minus. There's no good going into your exams without knowing the formula of the sulfate ion. And this test is another one of the precipitation tests, but we're using a different chemical to the ones for the cation tests, right? So the first thing you've got to do with the test for sulfate is prepare the test. And to prepare the test, you need to add some acid. Specifically, you need to add either HCl or nitric acid solution. So you can write the word solutions or write a little AQ after the acid there. Now, all that does is set the test up to work properly. If you don't add the acid, what can happen is that there might be ions present in your sample, specifically carbonate ions, that would spoil the test. Now, you don't need to know that in detail, but you need to know that you do need to add them to remove any, and I'm just telling you to remove carbonate ions or possibly hydrogen carbonate ions that spoil the test. What the acid does is it reacts with them and gets rid of them. Right, so once you've added the acid, the test is ready to do. And to do the test, you simply got to add to it a solution of barium chloride. So it has to be a solution. That's why I've written aqueous there. I'm going to write the word solution to emphasize it. You get a mark for saying barium chloride, and you get a mark for saying solution, or writing the little AQ there. So really emphasize that in your notes. You need to know there's no good doing a precipitation test without having the solutions. Make sure that if you're writing the formula of barium chloride, you've got a 2 there. Some people are missing out the 2 there, I think. Or give the name if you prefer. What we're really adding there is barium ions, and I'll show you the chemistry of it in a second. But the thing you need to know first of all is that you get a white precipitate forming. So the positive result is the formation of a white precipitate. That's what we call a positive result. So any of these chemical tests, they've got a positive result telling you that your thing is present. That white precipitate is barium sulfate solid. Right, so that stuff doesn't dissolve. That stuff is a white precipitate, and then that's what you get. So it's just simply something you have to learn. That this chemical test was, I know, in the 2023, maybe 2022 exam, I think. I can't remember actually. And you know, there's like 3 marks for it. You just got to know it. What's going on there is that the barium ions that are present in solution in the barium chloride bump into and then react with any sulfate ions that might be present. And as soon as they bump into each other, they cling on for dear life, and you end up with a precipitate. You end up with a solid forming. As soon as they bump into each other, they form an insoluble solid. I've got a nice analogy for that, but I'll do that off video. Okay, so there we go. That's the first chemical test. The other test we've just done is the test for carbonate ions, which is very straightforward. This is probably the easiest one to remember. Again, you need to know the formula of carbonate ions. So it might be sodium carbonate, it might be magnesium carbonate, whatever, but it's carbonate ions. It's CO3, 3 oxygens, and it's overall a 2- charge. So what you do for that is simply add an acid, typically hydrochloric acid, and then what you will see, the positive result is fizzing or bubbling or effervescence, if you feel like being fancy. But if you want to be sure that that gas is carbon dioxide, you can't see that it's carbon dioxide. We know that it's carbon dioxide given off. To prove that it's carbon dioxide given off, you can bubble the gas through lime water, of course, as we did a couple of lessons ago, which would go cloudy. And what's going on there chemically is that the carbonate ions, I know we haven't studied acids yet in any detail at all, but acids are things that put H plus into solution. That's all acids really are. And what you produce when you chuck acid into carbonate is you get water, and carbon dioxide being produced. And that's aqueous, that's the acid, that's water that you can't see, and that's the carbon dioxide that will fizz. That's all that's happening, and that could be magnesium chloride, magnesium carbonate, it could be hydrochloric acid, and that's it. That's what you need to know. Right, what we're going to do now is we're going to do another set of chemical tests, and we'll come back to the notes in a moment. So I'll pause this. Just to go back briefly while you're clearing up to this idea of carbon dioxide being given off and testing that with lime water. The way that you can do that, by the way, which I didn't mention, is it might be you do the test in a test tube like so, you add the acid in there, and the way that we pass the gas that's produced through lime water might be to pass through what we call a delivery tube, and that delivery tube will dunk into some lime water. That's how we do that testing. So the carbonate and acid reacting there, fizzing, and the gas bubbles through lime water and it goes cloudy like so. That's the way we do that. What you've just been doing now though is the test for the halides, and the halides are the following. So tests for halides we can make a note of. Sometimes we write halides, by the way, as X minus. They're all the same as each other. They're all in group 7. When I say ide, it's the negative ions, isn't it? It's chloride or bromide or iodide. The test is identical for all of them. So that group 7 of the periodic table. Now, what we would do for that chemical test is first a nitric acid, so HNO3 has to be solution, and that again, just like before, was to remove any ions that spoil the test. It's to prepare the test to work properly, to remove ions, carbonate particularly, that spoil the test. It's no good adding hydrochloric acid though, because hydrochloric acid contains chloride ions, and so that would add that's an important detail, not HCl. If you add hydrochloric acid, you're adding chloride ions to the solution, which means you're going to spoil the test. So you can't use hydrochloric acid for this one. You must use nitric acid. It must be nitric acid. So let's just really highlight that. For this chemical test, it must be nitric acid. Excuse my writing there. Must be nitric acid. And it's easy to remember because the chemical test for the halides requires silver nitrate. Okay. So then, for the second part, add silver nitrate solution. The silver nitrate's not something you've come across before, I suspect. There's those little dropper bottles. And the formula for silver is Ag. Nitrate we know is NO3. Silver's a 1+ ion, so silver nitrate is Ag NO3 because nitrate is a 1- ion. So the nitric acid, which also contains nitrate, and the silver nitrate are sort of related to each other, which is why we had that acid and not hydrochloric acid, I suppose. Right, so what's going on there? The positive test, positive results. They're all really similar, but they're slightly different, and you have to know them. So you get marks for knowing the test, you get marks for knowing the result, and you get marks for being able to explain the result by showing the chemistry. So this is really tempting to think all it is like a 1 marker. There's potentially a heap of marks in this, which is why we'll practice like crazy before we do any kind of a test on it. So the positive result for chloride is a white precipitate. And by the way, that's silver chloride. The test for bromide is really similar. That's the one that I demonstrated to you. That was ever so slightly creamier than white. But that's a cream precipitate, and you might be able to guess now that that's silver bromide, which is insoluble. Silver chloride's insoluble, silver bromide's insoluble, and silver iodide's also insoluble, which is why we see a precipitate for this too. And that one, I think you noticed, was a little bit yellower again. And what the exam board want you to say are those colours, so white, cream, yellow. Notice that they go down the periodic table, they get darker, if you like. So white at the top, then cream, then yellow. So you can remember them quite easily. It's quite difficult to tell silver bromide and silver iodide apart. Put a little S there to show you their solids. And there are ways of distinguishing them that you learn in some courses, but we don't need to know that. So you might see that if you're looking them up online. Okay, so that's the tests for the halides. What you need to know also, though, is what's happening from a chemistry point of view. So the silver nitrate, all it really is a source of silver ions. So when something dissolves, the two ions separate from each other. The nitrate goes off and does its own thing, has nothing to do with any part of the reaction here. But when a silver ion bumps into a chloride ion, both of which, remember, are in solution, we'll keep making that point as we practice. They bump into each other, you end up with silver chloride produced, and exactly the same thing for bromide. And exactly the same thing for iodide. So white, cream, yellow precipitates. That's the chemistry of it. So again, just to be clear, you need to know what the test is. In other words, be clear that it's a solution of nitric acid added to a solution of the halide. Then you add a solution of the silver nitrate. Keep emphasizing the word solution. Then you need to know the results, the positive results, if the halide is present. And you then need to know how to write an equation about it. And none of it's very difficult, actually. It looks kind of complicated on the face of it. Just quite a lot to learn for this whole topic. And that's it. That's what you need to know.